Yeah, so our library name is basically Data Purifier. First, we'll import all the necessary packages such as Data Purifier, Pandas, Seaborn, and etc. So Abhishek, just run that, sir. Abhishek, go down.
Oh,
Yeah. So for demonstration purpose, first we will select the most basic iris dataset and we'll load the dataset. So Abhishek, just load that dataset. Yeah, and you can see the first 5 rows of the data set. Then we will make a constructor call to ML EDA and pass the iris data frame. Yeah. So the first thing you can notice is Abhishek, run that, sir.
it's run.
Yeah. So the first thing you will get is the shape of the data frame, which is 150, 5. So 150 is basically the number of rows and 5 is the column number. So next thing you get is a sample of data frame which will show 10 random rows in the data set. Afterwards, you can see that the model correctly identifies one categorical feature, that is the species, and the other 4 numerical features. Then you will get a table which will display the count, mean, standard deviation, minimum, quartile 1, quartile 2, and quartile 3, and the maximum. Then lastly, it tells whether there are null values present or not. Then we will display the 5 most important plots. So the first one is count plot. It shows the count of observation of the selected column using bars. So you can see when you select the species, Abhishek, select species. Yeah, it tells the count of each category from the graph as well as in the table that is displayed. So there are 50 flowers of versicolor, 50 of virginica, and 50 of setosa. Next, we have joint plot. Yeah, so joint plot which visualizes and analyzes the relation between two variables and shows their distribution on the same plot. So we will select x-axis as sepal length and y-axis as sepal width, and the kind would be scatter and the u will be species. So you can see the plot below. Yeah, so this is the plot. Next we have correlation heat plot map. So it checks the correlation among the columns by visualizing the correlation matrix as a heat map. So you can see the correlation heat map plot. Now to see the pair plot, we can click on the checkbox and select the U parameter as species. Yeah, click on the checkbox. Yeah. So the pair plot produces a matrix of relationship between each variable in your data for an instant examination of a data set. Lastly, we have pie plot. Now, pie plot shows the percentage between categories by dividing the circle into segments. So you can see that the circle is equally divided into 3 parts. Each category of flower comprises 33% of the total data, which indicates that we have a perfectly balanced data set. Next, Abhishek will be explaining.
Thank you, Ansh. Coming to the next part of the library, that is the natural language processing part. So in this, we have first we will be seeing the data purification. Before explaining this particular library, I have to import all of this, that is NLP Purifier and NLP EDA. So, and this particular, both of these functionalities has been completely new. That is, there is no particular library present currently in the world to provide this particular functionality. So it's pretty new. So first I will create a sample dataset which I've made myself to explain this for demonstration purpose. Next, I will make a constructor called to NLP Purifier, which basically to clean the natural language dataset, I will pass this particular data frame, that is the example data frame, in this as a parameter, as well as the column name, which contains all my text data. So I will I will run this particular cell. After running this particular cell, a GUI will appear before you. Then you can select all the cleaning methods which you wish to clean your data set. Suppose I want to select couple of methods, like I want to drop all of the null rows. I want to lower all the words. I want to use contraction to. I will explain this. What is contraction to expansion? I want to count all of the URL in particular sentence. Get the word counts. Count email. Okay. Remove numbers and alphanumeric words. Remove all the special characters, accented characters. I want to remove all the URLs as well as emojis. I can select multiple options like this. I want to remove mails, multiple spaces, HTML tags. I want to convert emoticons to words. I will explain what is emoticons. After I am satisfied, like I have selected all of this, I can select whether to choose technique like stemming or lemmatization to convert the word into base form, or I can remove the top common words, or I can remove the top rare words. So just to keep this demonstration short, I will skip this to process. I will click on the button, start purifying. As soon as I click on the button, the data has been purified. You can see that the purification has already completed within a matter of seconds. If you implement this particular library from scratch, it will take you a couple of days, and you have to write a couple of thousands of lines of code to process it. And you have to means you have to consider almost various scenarios. Like you have to first count, then you have to remove all of this like URLs and everything. You have to consider various scenarios. But this particular library does all of those things for you. Next, you can see the log of this particular purification. Like first, it has lowered the file, and it is executed in this particular seconds. Then contraction to expansion has happened in this particular time. You can see all of the log in this particular file. It also shows like how to access those particular object which has been created during the process. So after this, all of this log, you can just access this particular data frame. Okay, I will just now let us compare with the original data frame to see what actually has been purified. So you can see over here. I will maximize the screen. You can see that this contains all the original example contains all the uppercase letter. It has converted to lowercase. This is basically an example. The second example is for contraction to expansion. This I would. This is short for I would. It has been expanded to I would. Okay. Next, this email has been removed, and the count it is stored in another column name as email, and the count of email has also been increased. Similarly, for the website, this website has been removed, and the website count is increased. All the punctuation and special characters has been removed over here. You can see added and hashtag. This sentence was having originally multiple spaces, but the formatted one has only single space between the words. Next, HTML tags has been removed. Accented text has been removed. So this is basically an example for accented text. This letters A dash and something similar like that. It is converted to normal text, and then it is, since we have applied the lower function, so it will convert the whole text into lower. Next, if the words like if I am not chosen over here to remove the stop words, if I have chosen the remove stop words, this particular example is for removing stop word. It will remove many and so and try. And for this example, for this second example is for stemming and lemmatization. So this run, ran, running, runs, all of these four words have similar meanings if in the root word. So all of this, if I have choose some stemming or lemmatization, this all four words have been converted to run, 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 and run. Okay, all of four words. Next, I have removed this particular number. You can see this alphanumeric word has been converted to just a word. This emojis has been removed. You can see, and this laughing emojis also removed over here. And this particular icon, you can see this colon, hyphen, and bracket. This is basically a this message we type on WhatsApp or YouTube or something. This particular icon is it's called emoticons. So in the previous section you have seen, I've checked the checkbox to convert emoticons to words. So this particular emoticon has been converted to its respective words, like happy smiley face. So this was the data purification for NLP. Next, coming to the last part, that is the EDA, automated EDA for natural language dataset. So first, we will get all the datasets. Like we have include some example dataset also. You can execute this particular cell to get all the dataset names. So this is included in a library. Okay, but including datasets in a library will increase the package size. Okay, and it will make difficult to download for the user. So what I did was basically I made another repo, online repo, and I fetch all of this library via wave flipping. I fetch all of this, and then I'm showing in overview via function call. Next, you can execute to get all this particular libraries, and then if you want to see only text data, you can execute this particular cell. It will show only text data, the dataset which is only text based. Next, you can load dataset. This loaded dataset. This requires internet connection because it is directly fetching from over here. This particular data repo. It will download this particular dataset for you, and then we will see the head part. That is the top 5 rows of the data frame. I will execute this particular cell. It has been downloaded since I've already run. It is cached in my memory. It is not downloaded. But if I run for the first time, it will show downloading and all that. So next, I will select the column to keep the demonstration as soft. I am only selecting this review and rating column. Next, for the analysis purpose, only this short line of code you have to execute. Nothing else you have to do for the exploratory data analysis. You have to just run this particular cell. After running this cell, the data set, you can see the data frame consists of around 23,000 rows, and it has 2 columns. Okay, and it shows that data frame has some null values. That is 845 rows have null rows in the data frame. So it is asking me to drop all the null rows in order to continue the analysis. So it is necessary for EDA to drop all the null rows. I will check this. So you can see 845 rows has been dropped, and this is the new size of a data frame. Okay, you can see this particular data frame. This is review and rating, which is from original data set. You can see the total word count this particular sentence was 8. Total character count is 53. Average word length is 5.75. The total stop word in this particular sentence was 2, and the uppercase word 1. This is important because in some of, like, if we write happy in bold letters in a WhatsApp or like in any social media platform, it means it has something more emphasis on those particular happy words, or sad. Okay, so count all of those words. I've included this particular count as well to count all the uppercase words. Next, you can perform the sentiment analysis as well. This for this particular, what I did was basically I loaded a sentiment analysis model from the existing library, and then I integrated with my particular library. So it will take it might take some time because there are around 22,000 rows it has to process. Okay, it has processed. So the sentiment will range from -1 to 1, being the most positive sentence. -1 being means negative statements, like it has some abusive words or maybe some bad language in there. Okay, and 0 means neutral statements. So you can see like this absolutely wonderful. It is a positive statement. So you can see it is pretty close to 1. You can if you can see the distribution plot also. You can see that is a right skewed matrix, a right skewed graph. You can see that most of the statements lie between like 0.25 to 1. So this is most of the statements in the review has been positively classified. Plus, you can see the distribution of a data set. Like I want to see like what are the total word length of the reviews. So I will see the word length. It will plot a graph for me, interactive plot. You can see this is the graph word length. Total there are 800 words in one of the reviews. That most of you can from the graph you can observe like most of the reviews at 800 words. Was length was around 800 words. You can hover over the paragraph to see the exact value. This particular review contained 98 words and around that. This completes the exploratory data analysis for the general exploratory data analysis of the NLP tool. Next is the process data frame you can access like this with the EDA.df. You can see all the polarities also mentioned over here. Whatever the processing you do, you can later access over here. Okay, that is a one feature. Next, for the word analysis, you can just execute this particular cell. Again, it shows like it has some null values. We have to drop those. Then you can see we can type a word and find a count of it. Like I want to know like how many times the word love has appeared in a review. So we can see like in the whole data set, more than 7,000 times the word love has been appeared. Okay, you can also visualize this particular word count by plotting a word cloud. Let's wait for a while. Okay, it has plotted. So since it's a fashion review data set, the most appearing word is dress, love, top, wear, size. So the more word occur frequently, the greater will be the font size. So you can observe from this. Then you can perform some analysis that are included, like performing unigram analysis. You have to just select the top word range, like 10, 20, and you can start the analysis. I will also perform, for example, I will perform a couple of analysis just to show you comparison between them. So it is say analysis has been completed. To view the data frame, I can this I can access via this method. So I will plot this data frame to make you better understand. So suppose for unigram analysis, it will basically show like the dress has this 10,000, more than 10,000 times the word dress has been occurred. The word has occurred around 8,000. This is for complete data set after processing everything. And this you can also see bigrams analysis also. Like the word which occur together, the word two size together has occurred around 1,000 times. The love dress has occurred around 700 times. So you can analyze like this. You can analyze the natural language data sets. So that's it for a demonstration. Moving on to the stats of this particular demonstration. Okay. Let me present. Okay. Moving on to the stats of this particular demonstration, I will show you the stats. Okay. So as you have seen, a library process provides many functionalities, and all you have to do is write a simple one line of code to access them. If you have to implement all of this from scratch, you have to write a couple of thousands of lines of code, and you have to take care of a lot of things during that, and it might take a couple of days to complete it. But now you can do all of this in mere seconds using a library. So the uniqueness and awesomeness of this particular library has can be proven by observing this particular stats. You can observe that within less than 1 month of release of this library, there is more than 3,600 total downloads of this particular library. So moving on to the final conclusions of this particular presentation, Ansh will do it. Ansh, over to you.
Yeah, so finally we have developed a Python library named Data Purifier, which is for automated EDA, automated cleaning, and automated pre-processing for machine learning as well as natural language processing. So using this library, users can perform some of the mentioned automated tasks via simple GUI in the Jupyter notebook itself, saving a lot of time and getting useful insights. Further, we would be focusing on the building the text to code model, that is the AI coder, which is with the main goal of easing the time consuming data science related tasks, and the users can refrain from remembering and writing long complex syntax and redundant code in the data science lifecycle.
These are some references that we have found out. Thank you, ma'am.